then the alternate exterior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. All right, so that's the one kind of outlier oddball of the group, or the consecutive interior angles is the oddball, I mean. All right, all the others are going to be congruent to each other. Right. Corresponding angles, alternate interior angles, alternate exterior angles. If the lines are parallel, those are going to be congruent to each other. It's the consecutive interior angles, which is the one that doesn't match the rest of them. And those are supplementary, or they add up to 180, right? So the last one, perpendicular transversal theorem. If a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other. So you got a pair of parallel lines, and you got a transversal that's perpendicular to one of those lines, then it's going to be perpendicular to the other. Which should make sense, because if this is a right angle right here, then its corresponding angle down here would be a right angle as well. So perpendicular to one is perpendicular to both. All right, so now let's do a little proof here. Given, anybody know what the given says there? What that symbol means? Parallel. So P is parallel to Q, or line P is parallel to line Q. And then we want to prove that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Which will be fun because there are no angle numbers, or it tells us the number of the angle, but it doesn't give us a measure for any of the angles. So, first step, always the first step of a proof, is to write the given, right? So P is parallel to Q. It's given. And then we've got try to come up with a way that we can show that the measure of angle 1 and the measure of angle 2 add up to 180. Which, if we look at 1 and 2, they're both exterior angles and they're on the same side of the transversal. So we really don't have an angle relationship set up that we know of that matches up with those. Right? There's not a direct relationship between those. If they're on different sides of the transversal, then we could use exterior angles theorem to do something with them. If they were both inside the two lines, so they were interior angles, then we could deal with those as same side interior or consecutive interior angles. But, so what we've got to do here is come up with a relationship between each 1 and 2 and one other angle. So I'm going to pick number 6 here. So we can come up with, or describe the relationship between angle 6 and angle 1 and angle 2. So somebody tell me, what's the relationship between angle 6 and angle 2? Anybody recognize it? They're corresponding angles. And what do we learn about corresponding angles on the theorems page? Corresponding angles will be congruent if the lines are parallel, and the lines are parallel, so we can say angle 6 is congruent to angle 2. And that's based on the fact that they're corresponding angles. And the corresponding angles theorem or actually it's postulate, corresponding angles postulate. All right, so that's the relationship between 6 and 2. And what's the relationship between 6 and 1? Piece of information we learned earlier in the year. Six and 1 are a linear pair, and because they're a linear pair, we know what else about those two angles. They add up to 180, or they are supplementary. So we can say that angle 1 and angle 6 are supplementary. And that's based on the fact that they're a linear pair. And what tells us a linear pair is supplementary is the linear pair postulate. All right, so now from there, we need to kind of connect the dots, so to speak. We got a relationship between 2 and 6 and 1 and 6. Now we need to use that information to come up with a relationship between 1 and 2. And since 6 and 2 are congruent, and 1 is supplementary with 6, then if 6 and 2 are the same, then 1 would also be supplementary with 2. So we can say that angle 1 and angle 2 are supplementary. And what we're using to do that is actually a theorem that we're having to use it kind of backwards here, because it's called the congruent supplements theorem. And the congruent supplements theorem tells us that if two angles are supplementary to the same angle, then they're congruent. So we're taking that kind of in reverse here and saying if two angles are congruent, then they would be supplementary to the same angle. Right? So same information, just looking at it in a different direction. And then since 1 and 2 are supplementary, what else does that tell us about 1 and 2? Their measures add up to 180, right? Measure of angle 1 plus the measure of angle 2 is going to equal 180 degrees. And what tells us that they're going to equal 180 degrees if they're supplementary? That's right, definition of supplementary angles. All right. Questions there? Anybody? All right. So on to this page, we're given that the measure of angle 2 equals 110 degrees, and we want to find each measure of the angles that they're providing for us down there. And once we give the measure, we need to also provide a postulate or theorem that supports what we did to get that answer. So, starting off, measure of angle 2 is 110 degrees down there. We want to find the measure of angle 8. Anybody know how we can find the measure of angle 8? So 8 and 2 would be supplementary. So 180 minus 110 will give us 70 degrees for angle 8. Anybody know what postulate or theorem it is that tells us that they're supplementary? The linear pair postulate. Right? All right, 2 and 8 are adjacent angles whose non-common sides form a straight line, so they're a linear pair, and the linear pair postulate tells us that they have to be supplementary if they're a linear pair. All right, so now for the measure of angle 1. So Angle 1's up here at the top. Anybody see a relationship we could build? So it corresponds with what angle? So angle 1 corresponds to angle 8. So we know that corresponding angles are going to be congruent. So 8 is 70 degrees. So measure angle 1 should be 70 degrees. And we know that based on the corresponding angles postulate. All right, so now let's look at angle 3. We want to come up with a way that we can figure out what it is without using something we've already used. So don't use a linear pair postulate or corresponding angles postulate. Is there another relationship we can use here? All right, so 2 and 3 are both exterior angles. They're on different sides of the transversal, so they're alternate exterior angles. And the alternate exterior angles theorem so what tells us that those are going to be the same. So 3 is also going to be 110 degrees. All right, so last one for the measure of angle 4. Can anybody come up with a reason that we haven't used yet? Find the value of angle 4. So we're not using a linear pair, not using corresponding angles, and we're not using alternate exterior angles. What's another angle that 4 is connected to that would tell us what its measure is? What do you say? So 4 and 8 are vertical angles. And what do we know about vertical angles? Vertical angles are congruent. And that's from the vertical angles theorem. All right. Questions there, anybody? All right, so moving on to the next one. Got this figure here. It says line AB is parallel to line CD, and line AC is parallel to line BD. So we've got 2 sets of parallel lines intersecting each other. We want to determine how many other angles have a measure of 100 degrees, based on that this angle right here is 100 degrees. So if this angle is 100 degrees, are there any other angles at this intersection that would be 100 degrees? Angle B right here, because it's the vertical angle to the original 100 degree angle there, right? All right. So then let's go down here to 1 and D. Either one of these is going to be 100 degrees. Right. D corresponds with the 100 here, or D is also an alternate exterior angle with B, so those would be the same, 100 degrees. And then, of course, its vertical angle would also be 100, so 100 there. And moving over to 3 and C, any of those would be 100. D is 100, C corresponds with it, or C and this 100 are alternate exterior angles, so C is going to be 100 here. And we can go with its vertical angle is going to be 100. And then up here to the last intersection, A or 2, which one of those is 100? The 2 is going to be 100. And its vertical angle then would be 100. So the answer to the question, how many other angles have a measure of 100 degrees? 1, 2, 3, 4, 5, 6, 7 red 100s there. 7 would be our answer. All right, now use the properties of parallel lines to find the value of x. If we look at them, we've got 72 degrees and x minus 8, which they're on different sides of the transversal, so they can't be corresponding. One is an interior angle and one's an exterior angle, so they can't use any of the interior or exterior angle theorems. So they really don't match up with anything that we have a direct relationship with. So can anybody come up with a way we can build a relationship between those two so we can solve for x? So which one are you saying corresponding? 72 with this angle? All right, so 72 corresponds with that angle there. So since these two are corresponding angles, they're both 72 degrees. And now what do we know about these two together? They're a linear pair, which means that they have to have a sum of 180 degrees, right? So x minus 8 plus 72 should equal 180. Or x plus 64 when we combine negative 8 and 72. Subtract 64. X is going to equal 116. And the next one, find the value of x. Here in this picture, we actually have two transversals. All right, we've got this line here, which would be a transversal, and the other line is transversal. They're both intersecting two lines. I'm just going to focus on that first one I highlighted. This one here. We had a 70-degree angle attached to it. So if we look at the top, there's actually two angles here. But if I look at this top angle going from the transversal to the parallel line that the transversal intersects, that angle includes two angles. And the 70-degree angle with that angle, these would be on the same side on the interior of the two lines. So these would be same side interior or consecutive interior angles. And what do we know about consecutive interior angles from the consecutive interior angles theorem? It's not congruent. It's the one oddball of the group. It's the supplementary group. So this angle here plus this angle down here should equal 180. But to get the measure of this angle up here, we actually have to add these two smaller angles together, like the angle addition postulate. So we're actually going to have x plus x minus 20 plus 70 degrees is going to equal 180. So all added together is going to equal 180. So it's going to be 2x minus 20 plus 70 equals 180. Combine the negative 20 and 70, we get 2x plus 50 equals 180. Subtract 50 from both sides. 2x equals 130. And our x is going to equal 65. So now that completes the notes. So section 3.3 in the homework packet for tonight.